Okay, let's talk about arrays and functions in C++ and how they work together. Now, let's first take the case of index variables being used as arguments into functions. Now, in this case, they work just like variables do. So let's take a look at an actual example. Let's assume that we have a function called my function that takes an integer. And then we've declared an array, and then we have an integer. Now, it's perfectly fine to call this function my function with an index variable such as a index n, or my function with a index 0. In both cases, these index variables will be passed as by value. So if they're changed within the function, the change won't be reflected outside. Now you can certainly change this to pass by reference, in which case index variables are passed by reference, and any changing them will be reflected outside the function. Now, passing whole arrays gets a bit more complicated because they are passed neither by value or quite by reference, but the behavior is closer to being passed by reference. When you pass whole arrays, the arrays decay into locations in memory where the array begins, or a pointer to the location memory where the array begins. We'll talk more about pointers in a later lesson. So we lose any sense of the size of the array because all we have now is a pointer into memory. Right. So let's take a look at an example of passing an array argument. So let's create a function called fillup that takes an array argument, array of type int, it takes a size, and if you define it, basically it loops through that number of elements and reads value from the terminal and assigns it to consecutive elements of the array. That's essentially what this for loop is doing, right? And if you were to call it in main, we would do it as follows. Of course, this is main, and you have the declaration up at the top and the definition below. Now we have declared an array of 5 integers called ages, right? We pass it into fillup, and then we check afterwards whether it actually did get filled up, right? A couple things to note here, that when we pass it in, this is basically a location in memory, a pointer in memory to the first element of ages, right? So the 0th element of ages, right? When you pass this in, it still does have a data type. It knows that this is a pointer in location into memory of type int. But what we lose is any sense of size of how big this thing is. So we have to pass in that size, right? So let's actually run this and see what happens. So I'm going to copy it. I am going to go to my IDE and I will paste it and I'll run it. It's going to prompt me for 5 numbers. So I'm going to enter a bunch of numbers and 5 numbers, and then I run it and I see that indeed it did get filled up. So let's go back. Now, what if you did not want your function to be able to change the array? What you would do is use the const modifier and put it in front of the array in both the declaration and the definition. So let's actually see what happens there. We're going to go back, and what we're going to do is we're going to change it so we're telling the compiler that, hey, this is an array. I don't want the function to be able to change. And you can already see the IDE is complaining here. So let's actually run this and see what happens. And it does give you a compile time error saying that, hey, you're trying to change a const array. The last thing I want to say here about arrays as argument is that you cannot directly return arrays like an array of integers, because arrays aren't really first-class objects and they typically decay into pointers. But obviously you can pass them as whole arrays, and if you modify it inside and you handle it properly, the value will be reflected outside.